that is from the top of the world.
Well, this sample, Kenton, is probably one of the most important samples of the whole expedition, so it's literally worth its weight in gold geologically.
A gloved hand brushes snow from a slab of gray limestone. The air is so thin it barely supports life. This is the death zone on Mount Everest, 29,000 feet up. But what emerges from the rock is not ice, but the delicate spiraled shell of a sea creature. This isn't just one fossil. The summit is littered with them. This is the starting point of an incredible scientific journey to understand a geological puzzle that defies all logic. A puzzle that tells the story of a world that was once completely unrecognizable and subject to forces of immense destruction. A puzzle above the clouds. Mount Everest. The name itself conjures images of superhuman endurance, blinding white snow, and the ever-present shadow of danger. It stands at an almost incomprehensible 29,031 feet, a jagged peak of rock and ice that pierces the upper limits of the atmosphere. For decades, it has been the ultimate prize for adventurers, a place where humans push their physical and mental limits to the absolute edge. But the most shocking secret of this Himalayan giant has nothing to do with the climbers who have reached its summit. You see, the real story is far older, stranger, and lies embedded in the very rock beneath their feet. What many overlooked for years while focused on the climb was the ground itself. The summit of Everest, this pinnacle of the terrestrial world, is not made of volcanic granite or pristine, newly formed rock as one might expect. It is largely composed of a dark gray rock known as the Komalangma limestone. And within this ancient stone is something that defies all common sense, something that should not be there. Fossils. But not just any fossils. The highest point on planet Earth is filled with the remains of sea creatures. This isn't a minor detail, it's a mind-bending geological paradox. Scientists and sharp-eyed climbers have identified the fossilized remnants of crinoids, which look like tiny stacked stone lilies that once waved in ancient ocean currents. They have found fragments of brachiopods, shelled creatures that resemble clams. And, most incredibly, they have found the faint outlines of trilobites, extinct armored arthropods that crawled across the seabed more than 400 million years ago. These organisms lived, reproduced, and perished at the bottom of a warm, shallow sea. The most shocking fact is that their final resting place is now the most inhospitable, high-altitude environment imaginable, where temperatures can plummet to negative 80 degrees Fahrenheit and the oxygen is only a third of what it is at sea level. To put it mildly, this discovery turns our perception of the world on its head. It's like finding a coral reef in the middle of a desert, or a polar bear fossil in the Amazon rainforest. The presence of these marine fossils demands an explanation, and it points to a history of geological violence and transformation on a scale that is almost impossible for the human mind to grasp. It tells us that the very rock that forms the summit of Mount Everest was not always a mountain. It was once something else entirely, something hidden beneath the waves of a long-forgotten ocean. How could this be possible? What force could be powerful enough to lift an entire seabed 5.5 miles into the sky? The answer would spark a debate that pits ancient beliefs against modern science. But the story of these fossils is just the beginning of the mystery. A drowned planet's proof. For centuries, long before the age of modern geology, people all over the world were finding things that didn't make sense. Farmers in the rolling hills of Italy would plow their fields and unearth perfect seashells hundreds of miles from the nearest coast. Miners digging in the Swiss Alps, thousands of feet up, would find the fossilized skeletons of fish. For a world guided by faith and sacred texts, there was one powerful and all-encompassing explanation for these impossible discoveries: a great global flood. Many people are crazy about the idea that these fossils are definitive proof. You can see this everywhere in history. The story, most famously told in the biblical account of Noah's Ark, describes a time when divine judgment sent 40 days and 40 nights of rain to cleanse the earth, causing the oceans to rise and submerge even the highest mountains. In this narrative, as the waters receded, the sea creatures that had been swept up in the deluge were left stranded, eventually becoming buried in the mud that would harden into rock. To believers, the fossils on Mount Everest are the ultimate confirmation of this story. What could be more convincing proof of a world-drowning event than finding the remains of sea life on the planet's most formidable peak? This interpretation offers a dramatic and, for many, a deeply spiritual explanation. It envisions a single cataclysmic event that reshaped the entire globe in a matter of weeks. The thing nobody tells you is just how widespread this belief was. It wasn't just a fringe idea, it was the accepted scientific and theological view for centuries. The greatest minds of the Renaissance and the Enlightenment looked at these mountaintop fossils and saw the unmistakable hand of God. What scientists found on Mount Everest of their day seemed to confirm their deepest held beliefs. These were not just rocks, they were holy relics, a permanent reminder of humanity's past and a warning for its future. But as the tools of science grew more sophisticated, a new story began to emerge. It was a story that didn't happen in 40 days, but over hundreds of millions of years. It didn't involve a flood of water from the heavens, but a slow, unstoppable flood of rock from deep within the earth. This new theory would propose a force so immense it could build mountains, move continents, and lift an ancient ocean to the sky. The stage was set for a monumental clash of ideas, one that would challenge faith with evidence written in stone. And the truth was more epic than any flood story could imagine: the birth of the Himalayas. The scientific explanation for Everest's marine fossils is, in its own way, as dramatic and awe-inspiring as any ancient myth. But not all things are what they seem, as this story doesn't happen with the sudden fury of a flood, but with the agonizingly slow, unimaginably powerful force of plate tectonics. To understand it, we have to travel back in time, not just a few thousand years, but hundreds of millions of years, to a world that would be utterly alien to us. About 250 million years ago, the landmass that we now know as India was not a part of Asia. It was an island continent far to the south, nestled next to Antarctica, Australia, and Africa as part of the supercontinent Gondwana. The land that would one day become the Himalayas was, at that time, the bottom of a vast ocean called the Tethys Sea. It was here in this warm tropical ocean that the trilobites, crinoids, and brachiopods lived and perished, their remains slowly settling on the seafloor and becoming entombed in layers of sediment that would eventually form limestone. Then, around 100 million years ago, a great rending began. The Indian plate broke away from Gondwana and began a solitary journey northward across the ocean. The thing nobody tells you is the incredible speed of this journey. In geological terms, it was a Formula One race. The Indian plate was moving at about 6 inches per year, which is incredibly fast for a landmass of its size. For tens of millions of years, it drifted, an unstoppable behemoth of rock floating on the planet's molten mantle. Ahead of it lay the massive Eurasian plate, the continent of Asia. A collision was inevitable. Around 50 million years ago, the two continents finally met. It was not a sudden impact, but a slow-motion crash of unimaginable violence that continues to this day. The immense force of the Indian plate driving into the Eurasian plate caused the crust of the Earth to buckle, fold, and shatter. Like the hood of a car crumpling in an accident, the land was pushed upwards. The ancient Tethys seafloor, with its layers of fossil-rich limestone, was caught in the middle of this continental vise. It was scraped off the descending Indian plate and thrust violently skyward. What was once the bottom of the ocean began its long, slow ascent to becoming the roof of the world. This process, known as uplift, has been happening for 50 million years. The Himalayas are still rising today, pushed a fraction of an inch higher each year by the relentless pressure from the Indian plate below. Mount Everest is a direct result of this colossal, ongoing continental collision. The fossils found at its summit are the irrefutable evidence of this process. They are the last vestiges of a lost ocean carried to the heavens on a mountain of buckled rock. But the collision didn't just lift the seafloor. It transformed it, deconstructing Everest. What many overlooked is that Mount Everest isn't just one solid chunk of rock. It's a complex layer cake of geological history, and each layer tells a different part of its violent creation story. The discovery of fossils is just the top layer of this incredible narrative. When scientists analyzed the summit, they found a clear sequence of different rock types, each one a clue to the immense forces at play deep beneath the surface. The very top layer, as we know, is the gray Kumalangma limestone, the 400-million-year-old rock that holds the marine fossils. This is the original seabed. But directly beneath this is a striking feature that climbers know as the yellow band. This is a layer of marble. Marble is what happens when limestone is subjected to intense heat and pressure. The heat and pressure from the continental collision literally cook the limestone below the summit, transforming its crystalline structure into a harder, distinctively yellow-tinted metamorphic rock. The fact that this transformation occurred tells scientists about the hellish conditions that existed as the mountain was being formed. Going deeper, beneath the yellow band marble, the story gets even more intense. The rock changes again, this time to a dark, flaky rock known as pallite and then schist. These are also metamorphic rocks, but they are formed from mudstone and shale, which were the layers of sediment that lay even deeper beneath the ancient Tethys Sea. The fact that these have been transformed into high-grade schist indicates that they were subjected to even greater temperatures and pressures, likely buried dozens of miles beneath the surface during the peak of the mountain-building process. Finally, completing this incredible geological narrative, we find a different kind of stone scattered within the lowest layers of the upper mountain, intrusions of brilliant light-colored granite. In a stark contrast to the ancient marine limestone above it, this granite is a relative newcomer, having formed a mere 20 to 30 million years ago. Its youthfulness is a critical clue, dating its creation directly to the most violent and energetic phase of the Himalayan mountain-building event, when the continental collision reached its cataclysmic peak. This rock represents the very heart of the collision. These are not sedimentary layers, but rather blobs of molten magma, superheated liquid rock that was squeezed up from deep within the Earth's crust under unimaginable pressure. As the Indian and Asian tectonic plates ground against each other, this magma was injected upwards, forcing its way into fractures and weaknesses within the older overlying rock layers. Trapped beneath the surface, insulated by miles of stone, this molten material cooled with geological slowness over millions of years, allowing large crystals of quartz and feldspar to grow before it finally solidified into the hard crystalline granite we see today. Viewed this way, these granite intrusions are far more than just another type of rock. They are the geological scars of the mountain's fiery birth. Like the healed tissue of a profound wound, they are a permanent record of the intense heat and tectonic violence that forged the roof of the world. They testify to a time when the mountain was not a static, frozen giant, but a dynamic, molten battleground of geological forces. Mount Everest is not merely a mountain, it is a colossal stone manuscript, a vertical timeline of our planet's most violent and creative forces. Each distinct layer tells a sequential chapter of its epic story, and to read the mountain from top to bottom is to witness the birth of a giant. We begin our descent at the summit in the thin, frozen air where fossilized shells of marine creatures lie entombed in limestone. This is the ghost of a once peaceful subtropical ocean floor, a silent testament to a world that existed long before the Himalayas were even a dream. From there, we descend through layers of rock that were buckled, folded, and cooked in the crucible of a continental collision. This is the cauldron of metamorphic heat, where the unimaginable pressure of two worlds colliding transformed ancient seabed into crystalline schist and gneiss. Now, we reach the mountain's very heart, massive granitic intrusions, the solidified magma that served as the engine for the entire event. This molten rock, forced up from the depths, powered the immense uplift that raised a seabed to the roof of the world. From a tranquil ocean to a furnace of tectonic fury, and at last to the towering frozen peak that scrapes the edge of space, the story of Everest is written in stone, a silent, breathtaking narrative for all to read. We've explored the science and the myth, but does the sheer majesty of Everest's creation hint at a power greater than we can measure? Like and subscribe for more mysteries.